All right, let's do it. Quiet. All right, look, we got gravity toward the center of the planet. We got normal force, that is surface on block. And if you only got these two forces, the block's supposed to be sliding down, but it's not, because you got, in this surface over here, you got a static friction. So the free body diagram is going to be, now I'm going to do the axis. This is going to be my x-axis, and this is going to be my y-axis. Here I got the normal force. I did it like that for convenience. I got mg, and I got a static friction. And this angle, as you see, these two lines are perpendicular over here, and these two lines are perpendicular over here. So there is a theorem that says if the lines of the sides of the triangle are perpendicular, the angles are equal. Now I'm going to do Newton's second law equations on the x and y axis. So in the x-axis, the sum of all forces acting on the x-axis is equal to mass times the acceleration in the x-axis. Then what we got on the x-axis, we got negative static friction, and positive, we got this component here, that is this over here, that is opposite to the angle, so it's mg sine of the angle. In the y-axis, we have the sum of all forces acting in the y-axis is mass times acceleration in the y-axis, and in the y-axis I got normal force positive, and this component over here that is adjacent to the angle, so it's mg cosine of the angle. Now, because the block is not getting into the surface, there is no acceleration along the x-axis, so this is always 0. Block not moving in the y-axis. However, because it's a static, because we are doing a static friction, the object is not moving in the x-axis because it's static. So now these two equations becomes this is going to be 1, this is going to be 2, and I got the third equation that relates a static friction with the normal force. This is an empirical equation. This is an empirical equation that relates normal force and static friction. So now I am going to substitute 3 into 1, so 1 becomes and solving for this is substitute 3 into 1, and now solve for normal force in 2 and now substitute normal force in this one. Now I divide by mg. And I'm putting sine to the other side. Now I divide by cosine. And mu static is sine over cosine, which is tangent. And this is how you find the coefficient of static friction, by just calculating tangent of the angle just before moving. And why is that important? Because this equation is actually like this, but just before moving, this equation is when the equal sign, and you can just do it. So if I start moving at 23 degrees, then it wasn't moving at 22.9999 degrees. So this is a good and easy way to calculate the static coefficient of friction.